We want to evaluate the given definite integral. To do this, we'll first find the antiderivative function using our integration formula here for cosine x. Then, once we find the antiderivative function, we'll use the fundamental theorem of calculus stated here to determine the value of the definite integral, where if big F of x is the antiderivative function, then the definite integral is equal to big F of b, where b is the upper limit of integration, minus big F of a, where a is the lower limit of integration. So looking at our definite integral, while we could factor out the coefficient of 2, I'm going to go ahead and leave it in. So we have the integral of 2 cosine x integrated with respect to x from 0 to 3. So first, the antiderivative of 2 cosine x would be equal to 2 times the antiderivative of cosine x, which we can see is just sine x. Remember, when performing definite integration, we'll leave off the constant of integration because the c's would simplify out when we find big F of b minus big F of a. So now we'll evaluate this at the upper and lower limits of integration. So we'll have some quantity when x is 3 minus some quantity when x is 0. So we'll have 2 sine of 3 minus 2 sine 0. Well, we should recognize that sine 0 is going to be 0, so the definite integral is equal to 2 sine 3, where we assume 3 is in radians. So let's go ahead and get a decimal approximation for this. We do want to make sure that we are in radian mode, so we'll press the mode key. Notice how in the third row we do have radians highlighted. If it wasn't, we would just move the cursor to radians and then press enter. And now we'll go to the home screen, second mode for quit. So now we'll enter 2 sine and then 3 close parenthesis, enter. So we can see the values approximately, let's round to 4 decimal places, 0.2822. Now I do want to take a moment and look at this graph over here on the right. This is the graph of the integrand function, or the graph of f of x equals 2 cosine x. I wanted to show this graph because notice how on the closed interval from 0 to 3, where 3 would be approximately here, a little less than pi, the function is both positive and negative on this closed interval, and therefore this definite integral does not equal the area bounded by the function and the x-axis. Notice how if we did integrate from 0 to pi over 2 radians, the function is non-negative on this interval, and therefore if we integrated from 0 to pi over 2 radians, it would give us this area here bounded by the function and the x-axis. But when we start integrating from pi over 2 radians to 3, because the function values are negative, the definite integral would actually be negative on this interval, or you can think of it as returning a negative area. So if we integrate from 0 to pi over 2 radians, this would be positive. But integrating from pi over 2 to 3, this would be negative. But notice how the positive area is actually more than the negative area, and that's the reason why the result of this definite integral is slightly positive. I hope you found this explanation helpful.